Okay, so I'm really hoping I can explain this in a way that will connect like some of the dots. So my friend and I were both looking at this, and she has a daughter. Her daughter's in high school now, but she remembers her daughter doing this. And we both kind of zeroed in on one part of the work, and like the middle of the night, it dawned on me how the flow of the problem goes. So the way the problem flows is it starts up there, and I'm sorry, I'm writing with my finger on the page, and then it goes over to the right. So the line on the left like feeds over to the line on the right, and then it moves down like and across like that. So like the way that we would read. And what hit me was the traditional algorithm that most of us know and we were taught, which is like great, except like I've never really thought that hard about why it worked. And what the work is here is it is the regular or normal way that we would think of dividing. It's just breaking it up into the steps. And so I'll try to show it to you, but when we're doing the regular division algorithm, we often will like we do the multiply and then we subtract and we multiply and subtract and we work the problem from top to bottom, and that's what they're doing here is they're multiplying and then they're doing the subtraction step in order. So looking at the problem, and I'll try to work it over here, and then I was playing around with it this morning during my quiet time, so I was kind of distracted. To do a couple other problems and show you how it works. So I would have normally set it up this way. So 861 divided by 7. And I would ask myself, how many times does the 7 go into the 8? And that's usually how we would start it. And then if it didn't, we would move over. And I have an example out to the side to look at that too. And so we would say, how many times does 7 go into 8? But it's not really 8. It's actually 800 because of the place value. So the way this method works is it's really leveraging the concept of place value. So how many times does 7 go into 8? And we would say it goes in once. But really, that's not a 1. Like we write it as a 1, but because of the location where it is in the final answer, it's in the hundreds place. So that 1 actually represents a 100, and that's where this 100 over here is coming from. So it goes in 100 times. Then we would multiply. We do 1 times 7, and we would write the product right underneath. And so, except I would argue that because of the location of the 7, that's not actually a 7, it's a 700 because it is falling into the hundreds place. And there's your 700. So from doing the multiplication. And then we would do the subtraction. And we do 8 minus 7, and we would get 1, and then we would bring down the next digit. Now, usually I would just bring down the 6, and then we just kind of work with that, and we leave the 1 hanging out up there. Maybe not everybody does it that way, but that's how I was taught. But tying it in with the work on the right, if we think of that not as 7, but as 700, and then we're subtracting, so we're literally doing the 861 minus 700, and then we could bring down the other 1. I mean, we don't usually, or at least I don't usually, but we could. And there's your 161, and then the process kicks in all over again. So this line right here, the 7 times 20, is playing off of the 161 from the previous line. So I would ask myself, how many times does 7 go into, and then usually that 1 wouldn't be there, so I would say 16. And it goes in twice. And so I would write the 2 there. But again, because of place value and where it is in the position, that's not really a 2, it's actually a 20 because of the place value. And then I would multiply 7 times 2, and I would get the 14. And there's the multiplication step over here, except it's not really 7 times 2, it's 7 times 20, which will give us the 140, and then we're going to subtract the 140 from the 161, and there we have it over here on the right. And so we would subtract, and again, I'm going to make the argument that that's actually a 140 because it's 7 times 20, and then we can subtract and we get the 21. And then the last step, how many times does 7 go into 21? Well, it goes in 3 times, and there's the flow of the work on the right. So we start working with a 21, and then 7 times 3 is 21. And then 21 minus 21 gives us the remainder of 0. And normally we would do that and we would say, okay, the answer is 123, remainder 0. So the traditional algorithm, working it out, like would work top to bottom, and then your answer obviously is found at the top. Whoops. Oh, credit, and I can't go back. Is at the top, and then on the other method, like you would just add up the 100 plus the 20 plus the 3. So what I was playing with this morning, when I probably should have been reading the Gospel of John, but that's neither here nor there, is I wanted to try it like with another one. And so I tried it with 9, like, well, I didn't really try it with this one, but that's what I have written down. So 934 divided by 4. And so looking at this, essentially, I'd be asking myself, like, so 4 times, and then it's got to be something like with 100, okay, because we're using that place value. So something times 100, and I want to get, it's like the Price is Right. I want to get like as close to without going over. And so I could, it would in this case be like a 200. So I want to get as close to the 934 without going over. And so that's the 800. Which is the same thing we do in that traditional algorithm, is like we say, well, how many times will it go in without going over? And so then we have 934 minus 800, which gives us the 134. And now I'm going to be working with the 134. So I want to get as close to 134 as I can, except this time I'm using a tens. So that would be, a 3. So 4 times 30, which would give me 120. And now I'm going to kick that out. And that gives me, 14? 12. Yeah, no, 14. I was looking at the wrong spot. Okay, and then the last one, 4 times, and then now we'll use a unit. So 4 times what? We want to get as close to the 14 without going over it. Or you could think, how many times does 4 go into 14? Like, it would be the other way of thinking about it. And it goes in 3 times, which gives me 12. 14 minus 12 is equal to 2, and that number is your remainder. It's what's left over. So this is where I accidentally switched slides. So there's my answer. It's 233 with a remainder of 2. And then just like for the contrast, the like traditional algorithm, I'm probably going to run out of space here, but we'd ask, how many times does 4 go into 9? It goes in twice. There's your subtraction. There's the 12. There's the 14, and it goes in 3 times, and then the 14 minus 12 is your remainder. All right, and then I wanted to show you one other thing, and I'm sorry if this video is getting long. You're like, I did not sign up for a math lesson. That's how my students feel, but I'm super nerdy. Is this one where, like, if we were going to do 124 divided by 5, so one where like it actually doesn't go in to the first digit and you have to move over. So we would be doing like 5 times. Now we could say like we want to do that hundreds, but like 5 times 100 is too high, so we're like overshooting it. So we would just cut down to like the tens position and say, okay, well, 5 times what? I want to get as close to 124 as possible without going over, and that is 20, which would give me 100. And then there's my subtraction. So I'm left with 24. And now we play that game with the 24, and that is a 4, because we get as close as possible without going over. And there's my remainder. So the answer would be 24, remainder 4. And of course, you can go do that out the regular way if you want to. But I hope that helped. Now, my mom, because I had to talk about this problem with everybody, her question was, how does that work with like double digit division? So if we wanted to do like 124 divided by, say, like 10. And I think it would work the same way, but I haven't played around with it. But I hope that that helps make sense of what the work is and connects it to the method that like you and I are probably much more comfortable with. And it really is kind of neat, and it teaches the kids how to pull apart the numbers and put them back together, and maybe show them when you do get to the traditional algorithm why it works. So this was actually a lot of fun for me to play around with. And if there's anything else that comes up, always feel free to send it my way.